Welcome to unit testing with SUnit, the mother of all unit testing, which is a framework from Smalltalk, which was a template for many other XUnit frameworks that we know today. And as you can see, this is a beginner's guide. So this is definitely not the only session that we are going to have about this. I will touch basics today, and if it's interesting enough, we can have follow-up sessions going into more details and more examples actually. So the plan for this roughly half an hour is to show some characteristics of a unit test in general, the procedure, what does it mean to say design by contract and what are alternatives, what about automation, and then we're finally going into SUnit by looking at the code. So as always, I'll try to keep the theory part short. Nevertheless, it's always good to refresh what we all have learned a while ago. So let me start by looking at the characteristics of unit tests. We are always testing single functionalities within code. It can be a class, a method, or methods, or even parts of a method. Because methods, in many cases, have different paths that you have a certain condition or certain states that you might run into different code parts, and in that case, you usually have a unit case for each of these. As you can see, what it says here is that in the V model, which I guess you know, so there's a V model, there's waterfall model, meanwhile there's agile and other paradigms. Unit tests are conducted before integration tests. Integration tests are on a larger scale, and they can combine unit tests, but much more importantly, which I'm going into more detail in a second, they don't necessarily only rely on, let's say, atomic isolated data or code that you have available, but they might include real data. Usually unit tests are white box tests. That means that the source code is known. There are also black box tests and other approaches for testing, which I won't go into details, but usually you know the source code and you write your test based on that knowledge. So looking at the procedure, this is actually relevant in terms of what I just said, that the unit test is not an integration test. That means we are testing the code that we're testing. We're not testing the environment. We're not testing dependencies and not testing dependent objects and data. So it's isolated, and you usually work with helper objects or proxies, and you test in isolation. Of course, for this, it's very helpful to have inversion of control or dependency injection, so that you can actually replace instances of certain objects that you need with fake instances. There are a couple of techniques, some of them are called dummies, fakes, stubs, mocks, and more. The difference is usually just whether they always return the same, or whether they return something depending on the input that you have, or whether they, like mocks, actually don't do anything at all and just get passed around. All of these are just techniques to isolate and abstract and make your code that you're testing independent from any external influences. Because if you want to test your class that is retrieving data from the database, you do not want to test the database or the data access layer or the ORM. What you will do is you will write probably a mock that will give you the data, and then you're testing how your class is behaving with the result, but you're not testing if the database is returning the correct data. So that's a very important part, and that's also the difference to, or one of the differences to integration tests and Previously, we've talked about the difficulty of, in an M2M solution, even writing unit tests because we have communication. Well, after what we just heard, I guess it starts to become clearer that actually unit tests shouldn't depend on that at all, whereas integration tests and other tests can. The procedure that we see here is setup, meaning, well, we set up all these helper objects, fake stub, mocks, and so on. We run the unit test, and then what we do is we do target actual comparison. So we have a certain assumption for return value, or for no exception to occur, or for an exception to occur, or for certain exceptions to occur. And this is what we compare with something that we define in the unit test. So what is the result, and what was the result that we expected? This slide is, as you can see, pretty simple, but it contains an important consideration, and that is, what does a unit test actually verify? Unit test never verifies that your code works or that there is no errors. All your unit test ever does is it verifies that the test criteria that you set up are met. And nothing more. So that's why we say black box versus white box test. Earlier I mentioned that in white box tests you know the source code, in black box tests you don't. And the idea of design by contract is that you don't focus on the algorithm, but you focus on the expected results. So in other words, you are trying to make sure that the contract, the agreement is met from the outside. So usually what your method returns and similar circumstances, and not so much that your algorithm is working, because this has something to do with external dependencies. And at the end of the day, this is what somebody will, or the parts that work with your code will notice, and not whether your algorithm as such works or not. And there are other terms that, basically sometimes you hear is that when you're writing a unit test, you're making sure that it behaves as expected, or something that comes more from the quality assurance, let's say, mind is that you say it's fit for purpose. So this is a term you will hear many times. Then I just want to say a few words about automation, which is obviously not the focus of this presentation, but it's still very relevant because unit tests usually make sense if they can and are automated. And this is a simplified version of the deployment pipeline where at the commit stage we compile, well, we certainly don't do that in Smalltalk, but in many other languages we do. We do a static code analysis, which we've heard of recently, and we also run unit tests, client-side, server-side, or both. That's a different question. But this is when unit tests are run. We have acceptance testing, which can be, for example, as I mentioned, integration tests, which run after unit tests have been performed. And we have something like capacity testing. So now we start with load and see whether the changes actually are affecting the performance of the system. Manual testing showcases in exploratory testing. So the easiest way you can imagine is someone just clicking on buttons and typing input into text boxes and clicks on submit. And after all that, hopefully we'll get to our release. Okay, so as I promised, short theoretical part, but I would like to offer to answer any questions that exist so far. Nope. Nothing? Okay. All right. Then we move on to Smalltalk. And what we see here is a VisualWorks image that we all know. And I would like to start with an overview of what there is. And there is a package that's called SUnit, and we have a couple of classes that in this session I won't go into all of them, but into some of them, and specifically into two, which is the test case, which is a subclass of the test asserter, and the test resource. If we start with the test case, then that is actually the one case that we're testing, and that is the class that we're subclassing. So if we want to verify that one condition that we referred to earlier, then this is where we typically would start. And there's different ways to do that. As always, in Smalltalk, you are not bound really to following the API. So you can override different methods than the authors had in mind. But you can also follow the way that the API, if you want to call it that, was designed. And that's the approach that I would like to follow now with an extremely simple example, because as I said, beginner's guide introduction, I do not want to make this complicated. All I want to do is simply show you a few basics. So test case, something that I thought of, which is really extremely simplistic, is just we're testing a module that returns 0. So basically, we say 0 returner test. And let me just change the keyboard layout, because otherwise we will see this X and Y flipped again. Now, if we look at what we have to override, there is actually not much. And what I would like to start with is actually now just creating an instance of that and see what happens. So this is our instance, so obviously there are no preconditions to initialize an instance of that class. And the main method that we're interested in is run. So if we call that entry point, that is actually the way it's designed to work and is rarely used, unfortunately. But if you do that, you get the full functionality of this framework. So if we call that and just execute it, okay, have I not initialized?
You have to mark everything, I think that's it.
Oh, okay. No, what is going wrong? Okay. New. I haven't. This was the class. Okay. Now if I call that, we see there is no error. So if I inspect the result, I see 1 run, 0 pass, 0 failed, 1 error. Why? We're going to understand it in a second. But the idea is that we have several resources that can be attached with the test case, but of course we don't have to have resources. The problem that we actually ran into is it's trying to perform a test, but right now it doesn't know at all what that even is. And there's an initialization, a class initialization method that is called selector. And the idea is that this tells us which is the selector that we're actually running on our test to perform the test. So if I instead say 0 returner test check for 0 and run this again, we will still have an error because the method doesn't exist. Now, if I go to the instance side and say tests, and say check for 0, and for now I'll just return true. And let's see what happens. We still have an error. Okay. Because we have to say selector, and this expects a symbol, oops, check for 0. Now let's see. Okay, now it passed. Obviously, the point of a unit test is not to return true or to do something, to actually perform some logic other than asserting. Now, the first step that I want to show you just to understand the concept is we can say self-assert 0 equals 0. So now we're using the different methods that we have to actually do the actual target comparison. And there are more than just asserts. There's assert, there's deny, which is the opposite, but there is also should raise, for example. There we can expect certain exceptions to happen, which can be extremely helpful if you want to test the negative case. The idea with the unit test is, of course, you're not only checking the positive case, but you're also checking the exceptional case. If we run this again, we get a passed. If we suddenly say, well, let's see whether 1 equals 0, surprise, we get a fail. Okay. So far, so good. Now, as I said, the unit that the logic that you're testing is, of course, it's not in the unit test itself. So usually, what you will have is some class that you're actually calling. That doesn't exist yet, but I guess we can just create it. And let's just create a new class which is called 0 returner. All right, core object, all good. Now the question is, how do we actually get this object into the test environment? This will be done by a resource, but before we even do that, let's just say return 0. So we actually have some logic in there. When was the last time you've seen such a simple object? It's easily understandable by everybody.
You should write more of them. Returner, 2 returner.
Okay. Now let's add a resource that I talked about earlier. Let's subclass this and say 0 returner. Yeah, let's just call it source. And of course,
Turn on the AC.
Okay. Of course, we will need an instance of this class that we just created. So 0 returner. Just do that. So now comes the part where we say we start our whole test, we set it up, and we can also, what Smalltalk calls it, tear it down. Now in the setup of this, don't tell me I just added this in this class. Okay, I did. That was wrong. First, we need to do that in this class, 0 returner. And once again, okay. Now we are overriding the setup method to actually create an instance of this class. And since this is the most simple object you can imagine, there's no need for a teardown because the framework is going to take care for us of basically removing the reference to this resource, and by that the reference to the 0 returner within that instance is going to vanish as well. So we don't need to take care of any tear down. Okay. Now the idea of resources is that we have a singleton, and how that works is by saying 0 return a test. We need to tell it which are the resources that you actually have. And we just need to tell it the class that we're using. So it's going to take care of creating that instance, the singleton instance. Okay. Now the next step I would say is that we're actually using this guy. And for that, all we need to do is get the singleton, which there should be a method current.
I think it's 0 returner resource.
Resource, correct, thanks. Resource. And now we get the instance. And of course, from that instance, we need to get our 0 returner. And there we call return 0. So to make this a little nicer, let's just use some instance variables. 0 returner. Returner equals this guy. And now all we need is this. And let's see what we forgot by just running it and see where it fails. Okay.
I think it's the same thing, that you wrote 0 returner instead of 0 returner resource when you were creating when you were adding the resource. I mean,
okay. So, okay, I think I see what you mean. So here
yeah.
0 returner resource. Thank you very much. That's okay. So let's look at what it's doing. It says run case, and run case. What it will do is it will go through all the resources, call available for, which will make sure that we have the singleton instance available, which, by the way, at the end we're going to destroy. We will call setup, which will call setup on all the resources that I have, and at the end we tear down. And as you could see, we passed because, of course, our 0 returner, which is simple code, was able to return the right result. So just for fun, our 0 returner suddenly returns 1. So that means someone checked in some code that should break our unit test. Let's see what will happen. Yes, we have 1 failed. These are the very basics of SUnit. It's important to remember that you should use these parts of the framework instead of manually overriding different methods, because this will give you the full flexibility. It will, for example, allow you to also use a customized version of test result, which you can use to send an email or to call a web service or something in case of different results. If you're starting to override let's say, other methods that are more specifically, you won't have such a functionality. The test suite, it is a combination of tests. So now, if I have a slightly more complex class than the 0 returner, or a slightly more complex method that, as I said, may have different paths that you can run through, you should still write unit tests for each of the cases, but you might just want to check, is all my zero returner related functionality still working? So you can create a test suite that will combine all of these. And typically that's what you do.
I have a question.
Yes.
I don't understand the usage of this test returner resource. My opinion was, okay, from what I know, usually you have a class and you have a test case for this particular class. Why do you need the resource?
Okay, so the idea of the resource is I would combine it, or let's say I would break it down to two things. One, if we look at the API, we have the advantage that setup and tear down is integrated into the framework. So all the preconditions that have to be met, creating and destroying any objects and resources that you need, they are taken care of you. Because you might need, for example, let's say you want to test a certain object like an asset with a certain name, ID, or features or whatever. You can initialize your data in the setup method. I mean, that's what you usually do.
So why do you do that in the test resource and not in the test case or in the test class?
Separation of concerns. So you might have different use cases, different test cases that want to use the same kind of test resource.
Ah, okay, I see. So it's basically just a base class.
Mm-hmm.
Ah, okay, forget everything.
No, it's a good question. I mean, it's setup and teardown and the idea of a single.
Yeah, okay. For me, I do understand. It's just, yeah, okay, you might have several test cases and they all want to create a standardized setup for the testing, and this is done by this resource class, and the testing is doing all the necessary things. Yeah, okay.
And funny that you mentioned that because even in the comment of the class, they say usually how it starts is you write your data in the setup method of the test case and later extract it through a test resource. So even they kind of figured that out.
Then you need to be careful, I guess, because if you've got a couple or many test cases using the same resource, and something changes as the default values at the resource, maybe you need to rewrite quite some test cases.
Yeah, I mean the typical way I did it before is to have one test class per class I would like to test, and then the setup is done is called just once, and all the test methods are in the same class, so you don't need this middle class. So yeah, okay, but I see this.
Okay. Actually, that is all, because as I mentioned before, I do not want to go into details, but I do think it makes sense to go into more examples in another session where you could show how it maybe even changes the way you write code when you have testing, because that's always